going to talk about is how to do particle pictures or particle diagrams with what we call limiting reagent style questions. Again, reason I'm going over this is because on the AP test, they've been doing more and more of these picture diagrams to try to visually give you an understanding of, you know, you start with so much, how much do you end with? So the model doesn't work great for numbers that don't divide evenly. So that is the problem with this situation. But I'm going to work this problem for you. It's on the back of your worksheet. It's nitrogen plus hydrogen gives you ammonia, the Haber process. So if I started with 56 grams of nitrogen and 6 grams of hydrogen, how much of the NH3 could be produced? So it's a limiting reagent problem in the fact of I have a certain quantity of everything, so how much do I make with that? So with all of these grams, I have to go to moles. So I divide the nitrogen, the 56 by 28, because that's the molar mass of nitrogen. So I end up with 2 moles of the nitrogen. And then I have 6 grams, so 6 divided by 2 gives me 3 moles. Again, just doing shorthand here. So if I draw 2 boxes, one for the nitrogen and one for the hydrogen, I'm going to show 2 moles, so essentially 2 molecules of the nitrogen. So nitrogen is going to be the open circle. Okay, nitrogen is going to be the open circle. And then the hydrogen is going to be the shaded in circles. So I'm going to draw 3 moles of those. So again, these are both diatomics. So I want to have them touching when I'm doing the drawing. So if you took honors chem, this is kind of how we started you with balancing, is to do drawings like this. So it's the same idea. So again, that's why I'm not going to spend a huge amount of time on it. So I make ammonia gas. Well, if I need 1 nitrogen and 3 hydrogens, okay, the hydrogens are really limiting me on how many ammonias I can make, because I have 6 of these circles here and I only have 4 of the nitrogens. So if I draw a nitrogen and then I draw 3 around the nitrogen, I will pretty much use up all of the hydrogen. Okay, so I have 6 colored in circles here. And then I have used 2 of the nitrogens over here. So what do I have left over is a nitrogen. 1 mole of nitrogen is in excess. So what you would see in the drawing is you would have 1 molecule that never reacted because it didn't need to, okay? So it's going back to that idea of, yeah, we conserve mass, but it doesn't mean that you always make the same amount of product as you start with. So I would want you to label the nitrogen as an excess, and you make 2 moles of the ammonia molecule as we have drawn it here. So it's just a different way of representing what we already have done. But again, it is limited to the fact that these all work out to be whole numbers. So I want you to try the other 2, and I want us to kind of brainstorm, well, how would you get around if you have a 1/2 mole of something or a 1/4 mole of something? How would you work around that in terms of these particle pictures? So that's what this is about.